why study solids? And the reason is that properties of materials depend on chemistry. Now, what properties do I mean? Okay, so like the first slide says, electrical properties. So you can see in this slide, I just sort of sketched together, sort of some groups of different types of materials. Here's some metals, quote, conductive polymers, metal oxides, semiconductors, polymers, glasses. That's all along here, just general groupings of the kind of materials you run into every day. And on this axis is conductivity, 1 over the resistivity. And what you see is it spans nearly 25 orders of magnitude. This is a property that can vary by 25 orders of magnitude. And the thing that's different between all these classes of materials is their chemistry. And so one of the objectives of this class is to give you a feel for what about those chemistries is related to conductivity. And it's not just electrical things. Well, you say chemistry, electrons, you know, there should be a connection. But there's also things like mechanical properties. By the way, you know, all these slides will appear as a handout on the web page. So don't worry about copying all this stuff down. Anything that goes up there will appear on the web page as a PDF. Okay, so mechanical properties. What do we mean by mechanical properties? Well, you know, brittleness, elasticity, all these things. There's all different types of failure stress. You know, there's all these different ways to describe the mechanical property of a material. One is simply what we call a modulus. So I'll use the epsilon here. So this is stress. Let's say Newton, force per area, meters squared. So this is the stress that I will put on my material. And of course, if I pull on something, it stretches a little bit. And that's called strain. And it's usually in percent, or delta L over L. Delta L is the change in length due to the stress divided by the length. And what this equation says is that there is a proportionality constant, which is a modulus. We call it a modulus. It's got the same units as stress, because this one has no units. Right? I'll be doing this the first couple of lectures is concentrating on units, because you're going to need that in solving problems. So let's look at one of these. How much does that change? Well, you can see here, this is a plot of elastic modulus, which is here. And here it is right here, Young's modulus, another name for it, versus density. And what you see here is a bunch of classes of materials. And you can see, look at the change here, 0.01, this is log scale, to 1,000, 3 to, that's 5 orders of magnitude. You got stuff down here, polymers, think of rubber. Low modulus means when I put a small stress on it, I get a lot of strain. And up here, ceramics, porcelain. Put a small stress on it, or a large stress on it, it doesn't stretch at all. High modulus. Well, if you stop and think about it, this stretching, at least for the homogeneous materials that are here, is bending of bonds. These properties, this macro property, is the accumulation of bending of bonds. And so there is a connection there, and it's up to you in this course, and we'll try and help you to make that connection. So that when you see this material, you may not even know what the chemical compound is, but when you see its behavior, you'll say, it's got to be this kind of chemistry. The other thing that's on here is some elements of materials that are not homogeneous. You can see here foams. They're composed of a material and air. They have very low modulus, but they're also low density. Right? Let's see. Oh, before I go to that, what about other properties? I won't go through examples, but optical properties. Transparency, birefringence. Birefringence is where the index of refraction changes with direction in the crystal. It's almost like in the material. It's almost like it's the speed of light varies with direction in the material. That's what's called birefringence. That's directly related to the bonds in the material. And of course, reactive properties. Think corrosion. One of the examples we'll use in this is sodium azide. Sodium azide is a compound, a white powder, that's used to make shaped charges that go in your airbag, or it's ignited and boom, it blows up to fill the airbag. We'll talk about that. Very reactive materials. Some you try to prevent the reaction, and others you try, like explosives, you try to make them react.